Topic: Construction processes. Soft soldering. Application and methods. Equipment. Types of solder. Fluxes. Safety. Introduction. The content covered in Grade 8 and 9 Agricultural Studies and Grade 10 Safety links in with the content that will now be covered. Grade 8 Safety. Grade 9 Safety. Grade 10 Safety. The purpose of this lesson is to provide content associated with soldering to treat. Concepts and skills. Soft soldering. Soldering is a process in which two or more metal items are connected by fusing in the flow of a filler metal. Solder: in the weld, the filler metal has a lower melting point than the workpiece. Soldering differs from welding in that in soldering the weld is not melted. There are three types of soldering, each requiring a higher temperature and each providing an increasingly stronger load strength. Soft soldering: use a tin lead alloy as the filler metal. Silver soldering: use an alloy with silver in it. Brazing: use a copper alloy for filling. The alloy of the filler metal for each type of solder can be adjusted to change the melting temperature of the filler material. Soldering seems to be a hot gluing process, but it differs significantly with gluing processes. Because the filler material alloys with the workpiece at the joint to form a gas and liquid tight connection. Soft solder's filler metal is characterized by a melting point below 220 degrees Celsius, while silver soldering and welding. Soldering require higher temperatures which are weighed by a flame or carbon arc welding apparatus to effect the melting of the filler material. Soft solder filler metals are typical alloys, often with lead, with melting temperatures below 250 degrees Celsius. Origin. Soldering and brazing presumably originated very early in the history of metalworking, probably before 4000 BC. Sumerian swords of 3000 BC were manufactured using hard soldering. Small statue is created by soldering. Soldering has historically been used to make jewelry, cookware and utensils, as well as other uses such as in assembling colored glass. Application. Currently, the two most common uses of soldering are in plumbing and in electronics, where they are used to connect electrical wiring and electronic components in printed circuit boards. It provides fairly permanent but reversible connections between copper pipes in plumbing systems as well as the loads in sheet metal objects, such as cans, rain gutters and car coolers, jewelry components, machine tools and some refrigeration and plumbing components are often repaired using higher temperature silver soldering processes. Each form of solder offers advantages and disadvantages. Soft soldering uses the lowest temperatures, but it is not a strong load and should not be used for load-bearing loads. It also cannot withstand temperatures and is thus limited to normal ambient temperatures or below. Silver soldering, as used by jewelers, requires the use of a flame or other high-temperature source and is much stronger than soft soldering. Brazing provides the strongest connection but also requires warmer temperatures to melt the filler material. Some examples of soft solder types and their applications include tin lead, general purpose, tin zinc for the welding of aluminium, lead silver for strength at higher than room temperature, cadmium silver for strength at high temperatures, zinc aluminium for aluminium and corrosion resistance, and tin silver for electronics. Step-by-step instructions. Secure positioning of soldering iron. When using a soldering iron, be careful not to burn yourself or any part of the vehicle you are working on. The tip of the soldering iron is hot enough to melt metal solder, so make sure it is in a safe place and does not touch anything. Prepare the wires to be connected. Remove an appropriate amount of the protective insulation around the wires while the soldering iron is heating up. Always use a proper stripping tool that is in good condition. Load the wires mechanically. Twist the wires together to make a good mechanical connection between them. If there are impurities in the solder, and the wires do not touch directly to each other, there may not be a good electrical connection. Although there may be a strong physical connection. This is known as a dry connection. It is also very important that the surfaces are very clean before soldering is done, otherwise there will be a weak connection. Place solder on wires. Use the soldering iron to gently heat the wires and melt some solder. Place the soldering iron on the wires to ensure that only enough solder runs in the wires. Be careful not to use too much solder, and if you apply too much heat you will melt the wire insulation. When you have finished soldering, clean any excess flux with a cloth and a little solvent from the weld. Place a casing over the load. Once the electrical connection is made, and it has cooled enough for you to handle it, you can cover the load with an insulator. It can also be electrical insulation tape, isolation tape. Turn on the solder. Give the wires a thin preparative layer of solder. This is called tinning of the wires and helps to make the final connection. Prepare the surfaces with flux if not absorbed into the core of the solder. Place the wire back in the terminal, and place the soldering iron on the terminal to get it hot enough to melt more solder between the terminal and the tinned wire. Be careful not to use too much solder, and if you heat the terminal too much, the wire insulation will start to melt. Cover the terminal. Once the electrical connection has been made, and it has cooled down enough for you to handle, you can place the insulator cover over the terminal and test the connection. Equipment. Hand soldering tools includes the electric soldering iron, with a variety of points available ranging from blunt to very fine points, and the soldering gun, which offers more power and which builds up heat faster so that larger parts can be soldered. Hot air guns and pencils allow rework of component. Solder flame is a type of soldering device that uses a flame, rather than a soldering iron tip to heat the solder. Solder flames are often powered by butane and are available in sizes ranging from very small butane/oxygen units that are suitable for very accurate but high-temperature jewelry work, and the full-size oxyfuel device that is suitable for many larger works such as copper pipes. A copper soldering iron is a tool with a large copper head and a long handle that is heated in a smoldering fire and used to provide heat on sheet metal for soldering. Wire brush, wire wool and emerald cloth are commonly used to prepare plumbing welds for the weld. Electronic joints rarely require mechanical cleaning. Alcohol and acetone, one or the other, is commonly used with cotton swabs or brushes to remove flux excess. A heat sink, such as a crocodile clamp, can be used to protect harmful heat-sensitive components while soldering. The crocodile clamp absorbs the excess heat and thus protects the sensitive components. Types of solder. Solder filler material is available in many different alloys for different applications. Electronic circuits requires eutectic alloys of 63% tin and 37% lead. 60/40ths. Other alloys are used for plumbing, mechanical connections, and other applications. Ordinary solder alloys are mixtures of tin and lead, respectively. (63/37ths) melts at 183 degrees Celsius. 60/40ths melts between 183 to 190 degrees Celsius. 50/50 melts between 185 to 215 degrees Celsius. For environmental reasons, and the introduction of regulations such as the European restriction of hazardous substances, lead-free solder is increasingly being used. It is recommended where young children come in contact with it, because young children tend to put things in their mouths. Soft solder fluxes. The purpose of the flux is to facilitate the soldering process. An obstacle to a successful solder joint is an impurity on the environment of the joint, e.g. dust, oil or oxidation. The impurities can be removed by mechanical cleaning or by chemical means, but the elevated temperatures that melt the filler metal, the solder, cause the workpiece and the solder to oxidize again. This effect is accelerated when the soldering temperatures are high and can prevent the solder from combining with the workpiece. One of the earliest forms of flux was charcoal, which acts as a reducing agent and helps prevent oxidation during the soldering process. Some drugs go beyond the simple prevention of oxidation and also serve as a form of chemical cleaning, rust. For many years, the most common type of flux used in electronics, soft solder, was glue-based, using the glue from selected pine trees. It was non-corrosive and non-conductive at normal temperatures. Plumbing and car applications, among others, usually use an acid base, hydrochloric acid, flux that requires cleaning of the load. This load cannot be used in electronics because they are conductive and because they corrode the small diameter wires over time. Soft solder fluxes are currently available in 3 basic formulations. Water-soluble streams, no requirement for removal, a high-activity flux designed to be removed with water. After soldering, no cleaning fluids that are fluffy enough and not needed to be removed due to the non-conductive and non-corrosive residue. Traditional adhesive fluxes are available in a non-activated, slightly activated and activated formulation. The fluxes contain glue combined with an activating agent, typically an acid, which increases the erosion of metals. Safety. Personal safety. When performing a task in the workshop, you must use personal protective clothing and equipment that is appropriate for the task and that complies with your safety regulations. These may include the following items: work clothes, such as overalls and steel-coated shoes. Eye protection, such as safety glasses and face masks. Overprotection, such as earwax and earwax. Hand protection, such as rubber gloves and barrier cream. Respiratory equipment, such as face masks and valve respirators. Safety notes. The soldering iron tip should be very hot to allow solder to melt. Do not burn yourself with the soldering point. Do not inhale the fumes released during the soldering process, they can irritate your respiratory system. Do not use the electric soldering iron when standing in water. Never solder on a live electrical circuit. Make sure you understand and maintain all legislative and personal safety procedures. Points to note. Solder used in car electrical connections is an alloy typically consisting of 60% tin and 40% lead. Solder should easily change from a solid state to a liquid state and vice versa. Solder is available as solid or liquid core solder. Solid solder requires an external flux in the soldering process. Liquid core solder has a flux in its core. Fluid is needed to prevent the metals from oxidizing when heated. Fluid is usually acidic and must be removed after the soldering process so that the load does not wear out. Soldering is done with a hot soldering iron. The soldering iron heats up electrically or through an external source such as a butane or oxyacetylene flame. The soldering iron tip absorbs heat which is then applied to the material to be welded. Once they are hot enough, the solder is able to melt between the components. For a load to be successful, the soldering iron must be tinned. The tinning process helps in the transfer of heat to the wire. The soldering iron tip must be heated, and a small amount of the solder is placed on the tip. Excess solder is removed with a cloth. The soldering iron tip is placed on the wire so that the heat is transferred to the wire. Do not apply too much heat, otherwise the insulation may melt. Activity/assessment. Teacher must work out activities on the given content and provide them to the learners. Consolidation. The lesson covered all the content as required by the CAPS. The learners understand all the concepts and content.
Please like, share, and subscribe to the channel for more future educational videos.
Topic: Construction processes, arc welding electrode. At the end of the lesson the learners should understand the following concepts. Arc welding. Arc welding electrodes. Basic arc welding principles. Welding defects. Introduction. The purpose of this lesson is to expose the learner to the basics of arc welding. Concepts and skills. Arc welding electrode. Briefly describe an electrode/welding rod. An electrode is a filling rod with which the load is made. Consists of a metal rod covered with an insulating material called casing/flux. The purpose of the coating is to stabilize the current, melt impurities, helps to form slag, helps speed up the welding process. What is the purpose of the slag formed on the weld? Protect the molten metal from air pollution. Prevent the metal from cooling too quickly. Causes an even weld. Slag must be removed after welding with a hammer. Briefly describe each of the following terms. Arc flame or spark formed between the tip of the electrode and the metal to be welded. Shielded arc blue gas forming around the welding arc. Welding pool or welding bead. Place/pool of molten metal that forms directly under the electrode when an arc is struck. Penetration. When the metal being welded melts and the welding rod penetrates the welded object. Slag. Cover formed over the welded area during welding. Flux. Cover the welding rod. Tack weld the ends of two pieces to be welded to prevent the parts from shifting when you start welding. Welding run. A series of welding pools is called a welding run. Welding chipping hammer. Hammer used to remove slag from a welding area. Tabulate the different defects that can occur on electrodes and give the effect of each defect. Defect effect. A. Point of electrode covered with insulating material, no arc can be struck. B. Color code absent or unclear, difficult to choose the correct rod for a specific metal. C. Welding rod coating absent, current cannot be stabilized. Impurities on the surface of the metal cannot be melted away. Slag cannot be formed. Melting time delayed. An even weld is not possible. Protected arch cannot be obtained. Name 2 consequences that poor storage/storage conditions can have on electrodes. Electrodes rust. Damage to the coating. Briefly explain the welding term tack welding. Preliminary welding on the ends of the welded workpiece to ensure that the workpieces do not move apart due to the high welding temperature when welding. Briefly describe the process of how a welding arc is struck. Make sure that the earth cable clamp makes good contact with the welding table and workpiece. Use an electrode with the correct diameter that corresponds to the thickness of the workpiece. Adjust the amperes of the welding machine according to the table. Put on a welding helmet to protect your eyes. Start the welding by making a tight motion with the welding rod. A crackling noise is a sign that the welding is running smoothly. Make a zigzag motion with the electrode. When the electrode is stuck, bend the electrode back and pick it up. At the end of the weld, the snail must be removed with a hammer. Make a sketch of the welding arc. Cover. Core of the electrode. Molten metal. Melted flux. Shielding gas. Solidified flux. Electric arc. Melted pool. Describe the arc welding process. Electric arc welding is a process of fusion where electrical energy in the form of an arc is used to provide the necessary heat for the metals to melt. The different welding defects and the causes of each. Name of welding defect causes sketch. Insufficient penetration. Welding torch flame too small or amperes too low. Incorrect welding technique. Insufficient load preparation. Welding crater. Too large flame or too high. Arc current. Incorrect welding technique. Too thin electrode or rod undercutting. Too high amperage/current. Or too high flame. An incorrect electrode angle. An incorrect welding torch angle. Slag inclusion. The arc current is too low. Slag is not removed after each weld. An incorrect electrode angle. Improper preparation of welds. Insufficient penetration. Insufficient penetration. Too small root gap. Arc current too low or welding torch flame too small. Electrode or rod too heavy. Gas holes. Dirty metal. Base metal melts too fast. Welding metal cooled too quickly. Porosity. Too high arc current or too large flame. Too sudden removal of the arc or burner causes the molten metal to be polluted by atmospheric gases. Wrong electrode or rod. Adhesion. Incorrect welding technique. Wrong electrode or rod. Concave welding. Too little welding material. Deposited. Too large flame or too high arc current. Unequal leg lengths. Wrong electrode angle. Wrong burner nozzle angle. Activity/assessment. Teacher must work out activities on the given content and provide them to the learners. Consolidation. The lesson covered all the content as required by the CAPS. The learners understand all the concepts and content.
Please like, share, and subscribe to the channel for more future educational videos.
Topic: Construction processes, arc welding. At the end of the lesson, the learners should understand the following concepts: arc welding, safety, protective clothing, dangers associated with arc welding, arc welding machine, basic construction and operation. Introduction. The purpose of this lesson is to expose the learner to the basics of arc welding. Concepts and skills. Safety clothing and equipment. Study the sketch below and answer the question that follows. Name the serious effects that ultraviolet rays have on the human body. Burn the skin. May cause cancer. May cause infertility. What is the purpose of wearing safety goggles, welding helmet and an overall when welding or slicing? Snails. Safety glasses should be worn to protect the eyes when cutting snails or sanding metal with an angle grinder. A welding helmet is needed to protect the face and eyes from the rays of the electric arc. It also protects the face and eyes from the heat and splashes of molten metal. The helmet is made of a black color to reduce reflection of light. The glass is a dark color to protect the eyes from arc rays and sparks. The welding operators' eyes can be damaged if they are exposed to arc rays. The strap of the welding helmet is adjustable so that it can fit around the head. A long-sleeved overall made of tough material should be worn to protect you from the hot metal and sparks. While welding. Safety precautions. Always stand on a rubber mat when arc welding. It protects you from an electric shock. Where there are no rubber mats available, shoes with rubber soles should be worn. This is especially important in damp areas. Always make sure that the floor is dry, as electric shocks can be experienced if the floor is wet. Make sure that there is no flammable material in the area that can be easily ignited by welding sparks. A fire or explosion can easily be caused by sparks. Good ventilation is needed so you can breathe easily. Always make sure that the eyes of fellow scholars of the arc rays are protected by shielding the welding area with tarpaulin or special welding screens. Name the dangers of arc welding. Never work with a welding machine where the power supply is not connected to the ground leakage circuit breaker. Never stand in water and weld. Electrode holder must be thoroughly insulated. Keep flammable materials away from flying sparks. A helmet with clear glass should be worn to protect the eyes from flying snails. A screen with dark filter glass, which fits over the clear glasses, must be worn to protect the user from ultraviolet rays when welding. It is extremely dangerous to look at the open flame with uncovered eyes when welding. It can cause painful arch eyes or even blindness. Care must be taken when welding any drums. Explosive gases or substances can lead to explosions. Certain metals such as copper, manganese steel, and galvanized metals can emit toxic fumes when welded. Types of arc welding machines: electric current that can be used for welding. Alternating current. AC, direct current. DC, inverter welding machine, DC. Transformer welding machine. Suitable for all ferrous metals. Gives a smoother finish and the transformer is cheaper. Generator welding machines. Weld non-ferrous metals. Transformer welding machine. Transform AC to DC. Suitable for ferrous and non-ferrous metals. Study the sketch of a machine used on all farms, where electricity is available, to manufacture or repair articles. Provide labels. Welding machine. Electrode holder. Workpiece. Earth clamp. Discuss the function of the rheostat. To adjust the welding current by increasing or decreasing the amperes of the welding machine, when thicker or thinner metal is welded. Name the device used to hold the welding rod in position when welding, and give a reasons why this device should be thoroughly insulated. Electrode holder. To prevent the user from getting an electric shock when welding. Activity/assessment. Teacher must work out activities on the given content and provide them to the learners. Consolidation. The lesson covered all the content as required by the CAPS. The learners understand all the concepts and content.
Please like, share, and subscribe to the channel for more future educational videos.
Topic: Energy, charging of battery and components of an ignition system. At the end of the lesson, the learners should understand the following concepts: charging a battery, preparation and safety, personal safety, safety tips, potential difference, step-by-step instructions, the purpose of a battery in a car, reasons for a battery failure, how is a battery serviced, facts, questions and answers, the ignition system of a car, discussion of the ignition coil, the alternator, a spark plug, typical inflammatory problems, when to remove spark plugs, setting a car's time, wiring diagram of a trailer, basic components in the electrical circuit of a car, fuses, lights, wiring and trailer coupling plug. Introduction. The purpose of this lesson is to expose the learner to the charging of batteries and also the basic components of a car's ignition system. The learner will also learn the basic aspects of a car's wiring. Concepts and skills. Charging a battery. Summary. The purpose of this procedure is to show you how to charge a battery correctly using battery charging equipment. Before charging a battery, always carry out a visual inspection of the battery to make sure there are no cracks or holes in the casing. Personal protection. When performing a task in the workshop, you must use personal protective clothing and equipment that is appropriate for the task and that complies with safety regulations and policies. These may include the following items: workwear, such as overalls and steel-toe shoes; eye protection, such as safety goggles and face masks; ear protection, such as earwax and earwax; hand protection, such as rubber gloves and prevention cream; respiratory equipment, such as face masks and valve respirators. Safety tips. Make all connections between the battery charger and the battery that must be charged before connecting to any power or before switching on equipment. Should never attempt to charge a frozen battery. Make sure that the voltage used to charge the system is never more than what the system is designed for while charging. For example, if you are charging two 12-volt batteries in series to charge, you should use the 24-volt setting on the charger, but if you are charging the same two batteries in a parallel connection, you only need to use the 12-volt setting on the charger. Never allow a spark or flame to get too close to the battery. Always use the marks on the battery to determine the positive and negative terminals. Never use only the color of the cables to determine the positive or negative terminals. Make sure you understand personal safety procedures when performing tasks and observe all legislation. Ask your teacher if you are unsure about what this entails. Points to remember. Slow charging of a battery is less stressful/harmful to the battery than fast charging. Always remove the negative battery terminal first when replacing a battery to reduce damage to the vehicle, especially with today's electronically intensive cars. Use a memory storage tool to maintain electronic settings. After charging and installing the battery terminal must always be cleaned. A little grease can be smeared on the terminals to prevent oxidation. Step-by-step instructions. Examine the battery. Perform a visual inspection of the battery to ensure that there are no cracks or holes in the casing. Connect the charger. Make sure the charger is disconnected and turned off. Connect the red wire from the charger to the positive battery terminal. Connect the black wire from the charger to the negative battery terminal. Turn on the charger. Check the charger's amperage output to ensure that the battery is charging correctly. A slow charger usually charges at a rate of less than 5 amps. A fast charger charges at a much higher ampere rate depending on the original battery charge condition and should only be done under constant supervision. Briefly describe the purpose of a battery. Vehicle has a battery for starter car, windshield wipers, heater, radio, ignition system, lights, etc. The source for this power is a battery or accumulator. The battery used in vehicles is the lead acid type. It consists of lead plates immersed in a solution of sulfuric acid in a plastic casing. The plates are actually positive and negative plates separated by a plastic divider. The acid solution is called the electrolyte. Reasons for battery discharge. Short circuit in the electrical wiring of the car. Using the starter motor for a long time when the engine starts with difficulty. When the vehicle is only used for short distances for a long period of time and the battery cannot be fully charged by the alternator. Defective alternator. Short circuit between battery plates. Sulfate precipitation on plates. Use of impure water when recharging battery water. Broken connectors and poles. Cracked casing. Battery freezing at extreme temperatures. Excessive use of starter motor. The maintenance on a battery. Remove plugs once a week and make sure plates are covered with electrolyte. Fill with distilled water to 12 mm above plates. Provide alternator to ensure that the battery is not charged above or below. Test wiring for short circuits or leaks. Vehicles should not be stored with the battery connected. Any battery will discharge after a period of time. Short travel periods and unnecessary startup of the engine should be avoided. Clean battery terminals regularly. Apply vegetable oil to the terminals to prevent them from rusting. Clean terminals with a solution of baking soda. A terminal must be detached and bent open before reconnecting. Make sure the correct terminal is connected to the correct cable. Negatives are usually linked to the nature of the vehicle and the positives are connected to the starter. The function of the accumulator, battery, is to supply power to the entire electrical system of the tractor. Parts of the electrical system for which the battery supplies power. Spark plugs, petrol engine. Starter. Instruments. Headlights, or lights. Aspects that need attention when servicing a battery. Check the polarity of the battery before removing it. Always remove the earth clamp first. Clean the top of the battery with baking soda. Scrape the inside of the poles from the battery to remove rust. Check the level of battery acid. Check the polarity when replacing the battery. Disconnect the ground terminal after connecting all the other connections. Points to remember when replacing a battery. Replace with a battery of the same size. Replace with a battery of the same voltage. Make sure the battery is securely fastened. Carefully clean the battery and poles. Apply a caustic-resistant ingredient such as grease to the pool. Facts. What type of acid is used in the battery and what is used to dilute this acid? Sulfuric acid. Distilled water. What type of metal are the plates made of in the battery? Lead. What type of energy is used to generate electrical energy in a battery? Chemical energy. What type of current is generated by the battery? Direct current. Symptoms indicating that cables are faulty. The starter turns slowly. Cables get hot. Cables are covered with an acid layer. Cables are broken. Light shine dull. The trumpet is barely audible. Battery fully charged, but electrical parts. Works poorly. The function of the ignition coil. This is to increase the current voltage in order to cause an increased current voltage in the secondary circuit. Name 3 points of importance when replacing an ignition coil. Switch off the vehicle first. Determine the polarity of the coil. Make sure the coil is of the right type and capacity. What is the function of the distributor? It distributes the current to the correct spark plug. A diagrammatic representation of the inflammatory system. Accumulator. Ignition switch. Ignition or high voltage coil. Spark distributors. Emitter. Spark plugs. Primary conductors, low voltage. Secondary conductors, high voltage. Points when replacing a spark system. Does the capacitor provide a constant and strong enough current? Are all the contact points firmly attached? Is there a possible leak in either the high or low voltage wires? Is the opening of the points set correctly? Are the points badly burned? Is the rotor arm worn? Is the tip of the rotor badly burned? Are all the connections running from the bobbin to the rotor fixed? What is the function of the spark plug? Make a gap in the combustion chamber that causes the induced current to bridge the gap under high current voltage, producing a spark that in turn ignites the fuel-air mixture. Why do the spark plugs have to make a spark at the right time? This ensures proper combustion of the fuel. If the spark control is too fast, ignition takes place before the piston reaches BDP. If the spark control is slow, the spark will only ignite after the piston has reached BDP. Practical lesson. How to set a time frame with a stroboscope. Engine must be switched on. Attach the spark adjustment light to high voltage line number 1. Remove the vacuum advancement mechanism. Adjust the diaper speed according to the specifications. Set the timer light to the spark timing marks of the engine. Loosen the clamp bolt from the distributor. Turn the distributor until the timer marks match the manufacturer's instructions. (1) Timing light. 2. Low voltage guide wire. 3. Movable breakers. 4. Fixed breaker points. 5. Interrupter cam. 3 cases in which one removes spark plugs. For inspection and cleaning. When it is replaced. When a compression test is done. Symptoms of typical inflammatory problems. Engine difficult to start. Engine runs irregularly. Vehicle runs jerkily. Little power. Engine idles slowly. Black smoke at exhaust pipe. Function of a fuse in the wiring of a car. Protect electrical components and circuits from short circuits and accidental overcharging. Parts of an ignition system. Battery/accumulator. Starter switch. Starter motor. Alternator. High voltage coil. Spark distributors. Spark plug. Diagram of a coupling between a car and a trailer. Activity/assessment. Teacher must work out activities on the given content and provide them to the learners. Consolidation. The lesson covered all the content as required by CAPS. The learners understand all the concepts and content around charging a battery and the ignition system of a car. Note, the knowledge and skills you have learned here prepare you for the next part of the work.
Please like, share, and subscribe to the channel for more future educational videos.
Topic: Energy. At the end of the lesson, the learners should understand the following concepts: battery, ignition coil, distributor, spark plug, ignition timing. Learning content covered in grades 8 and 9 agricultural studies must link in with the current content that will now be covered. Basic 12-volt DC electrical energy. The purpose of this lesson is to expose the learner to the battery/accumulator of a motor vehicle. Concepts and skills. Battery/accumulator. Basic safety. Vehicles contain lead-acid batteries with sulfuric acid as electrolyte. The acid is highly corrosive and can burn your skin, but this is not the case if the battery contains a type of gel. Sealed batteries retain the fluid. Battery has removable plugs at the top. Do not turn batteries upside down. Batteries can explode. During the charging process, hydrogen gas is emitted and is highly flammable. Do not smoke near battery, also do not bring any open flames nearby. Frozen batteries are removed and placed in a warm room before charging. Always wear safety goggles. Battery that exploded. Safe jump start. Shock hazards. Batteries produce only 12 volts, so there is no danger of being shocked. However, the battery can generate hundreds of amperes, so never place a metal object such as a wrench between the positive and negative battery terminals to see if the battery will spark. This will also produce a current similar to a welding arc that could damage the instrument or the battery and slash or cause the battery to explode. Warning: on hybrid electric vehicles like the Toyota Prius, Lexus RX 400h, Honda Insight, Ford Escape Hybrid, etc. The hybrid battery pack in the back of the vehicle is a high voltage, 300 plus volts. Battery 300 plus volts is enough to shock or kill you, so never work on the hybrid electrical system of the vehicles without first turning off or disconnecting the high voltage battery as per vehicle manufacturer's instructions. This should be done with insulated tools and gloves. The high voltage wiring is usually colored orange. Safe battery jump start procedure. If a battery is dead or too weak to turn the engine on, you can jump start it. Jump start using some long jump cables by connecting the dead battery to a good battery in another vehicle. Pull the other vehicle as close as possible to the one with the dead battery, but do not allow the vehicles to touch each other. Open the bonnet on both vehicles, and shut off the engine of the other vehicle. Jumper/jump cables are color-coded, red for positive plus symbol and black for negative minus symbol. Do not replace the cables or allow the metal ends to touch, as this may damage the battery, charging system and/or electronic components on a vehicle. Connect one end of the red jump cable to the positive plus symbol terminal on the dead battery. The positive battery terminal will be slightly larger than the negative terminal, and will be marked with a plus symbol sign. There may also be a red plastic protective cover over the positive battery terminal. Connect the other end of the red jump cable to the positive plus symbol terminal on the good battery. Connect one end of the black jump cable to the negative minus symbol terminal on the good battery. Connect the other end of the black jump cable to a sturdy metal ground tip on the engine or frame of the vehicle with the dead battery. Do not connect the final jump cable to the negative or minus symbol point of the battery itself, as it will normally spark and the hydrogen fumes in the dead battery may ignite and cause an explosion. Note: on some vehicles the battery is not easily accessible, because it is located in a mudguard, panel, trunk, under a seat etc., so there may be special jump start connections in the engine compartment for the jump start of the vehicle. Warning: do not lean directly over the battery while making jump start couplings, in case of an explosion. Start the vehicle with a good battery, and let the engine run for a few minutes at a fast idle speed, 1200 to 1500 RPM. This will help charge the low battery so that the engine can be turned on more easily. Now you can turn on the vehicle with the dead battery. If the engine is not turning or turning slowly, the jump connections can be wound to make sure they make good contact. Then try again. The engine will start if there are no other problems, such as a defective starter motor or ignition circuit problems. Once the engine is turned on/off, both jump start cables must be disconnected. Do not allow the metal ends of the jumper cables to touch each other or the red cables to come into contact with metal on the motor at all. Keep the engine running for 20 to 30 minutes, or drive the vehicle to recharge the battery. Do not use the lights, heater, AC, air conditioner, and other electrical accessories during this time so that all the power from the charging system can flow to the battery to recharge it. Note: if the engine dies shortly after jump start, or as soon as the jumper cables are disconnected, it probably means the charging system is not working, bad alternator, voltage regulator, wiring problem, or loose/dirty battery cables. If the vehicle is running and the battery is charging properly, you must clean the battery cables and tie both battery connecting cables after shutting down the engine. The battery and charging system should also be tested to make sure both are working properly. Precaution cells when battery needs to be repaired. It is usually a good idea to disconnect the battery before doing electrical repairs. Disconnect the negative battery cable from the battery. This will prevent accidental damage to electronic equipment when wiring is accidentally shorted. Warning: never disconnect the battery when the starter is connected, or while the engine is idling or running. Doing so can damage electrical and electronic components. Warning: disconnecting the battery on some late model vehicles can cause handling or other problems. When the battery is disconnected, power to the PCM and other onboard modules is lost. This can cause a loss of keep on living memory settings. In effect, reset the PCM back to its basic settings, so that the engine cannot run properly until the PCM adjustment memory can reactivate these settings. The same goes for the transmission system. It cannot move properly, or does not feel the same, until the PCM or TCM has time to reset the shift adjustments. It can take 10 to 50 kilometers of driving to recover. Disconnecting the battery can also cause module system to forget their learned or programmed settings. It includes modules that control the air conditioner, sunroof, electric windows, power seats, radio, even some anti-theft or keyless entry systems. Some of these modules may not work properly when the battery is reconnected, or it may be in standby mode until a special scan reset procedure is performed, which requires a trip to the car dealer for repairs. So consult your owner's manual for any precautionary measures to disconnect the battery before removing the cable. If you are unsure whether disconnecting the battery on your car can cause problems, connect a friend's battery charger or memory device to the battery cables or the 12-volt power outlet or cigarette lighter before disconnecting the main battery. Never exchange battery polarity. It can damage the battery, charging system, electrical components or on-board electronics. Except for a few antique vehicles, all modern vehicles have a negative ground. The negative battery terminal is marked with a minus sign, minus symbol, while the positive battery terminal is marked with a plus symbol sign. Finally, when installing a new battery, make sure that the battery is fully charged before driving the vehicle. This will reduce the pressure on the loading system. Activity/assessment. Teacher must work out activities on the given content and provide them to the learners. Consolidation. The lesson covered all the content as required by the CAPS. The learners understand all the concepts and content.
Please like, share, and subscribe to the channel for more future educational videos.
Topic: Types of wood. At the end of this lesson you should be able to understand the following concepts: properties, uses and protection of wood and related wood products. Pine, wattle, blue gum, poplar and mayantai. Protection of wood products. Wooden poles, corner poles and beams. Wooden doors, types and construction. Introduction. Learning content covered in grades 8 and 9 agricultural studies must link in with the current content that will now be covered. The purpose of this lesson is to expose the learner to the basic concepts of wood and related wood products. Concepts and skills. Name 3 types of exterior doors: ledge door, ledge and brace door, ledge and brace pattern door. Name, identify and provide characteristics and uses of the 4 types of timber. Name: pine, Pinus spatula, poplar, blue gum, wattle. Picture. Characteristics. Soft. Color varies from yellowish white to yellowish red. Show clear annual rings. Resinous. Durable. Easy to work with. Easy to nail, varnish and paint nails. Softwood. White to straw. Colored. Fine article. Light. Easy to work with. Easily curved. Odorless. Relatively hard. Fairly elastic. Straw colored. Heavy. Absorb. Preservatives. Readily. Easy to work with. Very durable. Untreated wood is attacked by drill. Beetles. Slightly brushy. Pink brown in color. Fine wire. strong and hard with even structure, medium density, dry well, hard to process. Uses: packing cases and boxes, building material, furniture, paper and pulp, molds for castings, laminated wood, shipbuilding, gymnastic equipment, wood wool, matchboxes, toys, furniture, packaging material, woodwork, crates, firewood, laundry pins, power and telephone poles, building materials, furniture, supporter mine, packing box, wood saws, pressure passages, livestock, poles for fences, crates, bark used for tanning, charcoal, firewood, floors, cardboard, poo pail. Activities. Teacher must work out activities on the given content and provide them to the learners. Identify the wood you can use as a corner post in a fence and give a reason for your answer. Blue gum. Hardwood / weather resistant / insect resistant. What protective measures can be used to prevent weathering of wooden poles used for fences? Treat poles with creosote. Creosote penetrates deep into the wood and is not easily washed off. During a practical period, learners must be given the opportunity to identify different doors in the school building. Learners must identify different types of wood and name their uses. Learners go on an excursion to a local cooperative or hardware store where they receive a lecture on the different wooden poles used for construction and fencing on farms. Consolidation. The lesson covered all the content as prescribed by the CAPS. The learners understand the content, concepts surrounding structural materials. Values. By studying this lesson, you should be able to know and understand the types of doors and wood. Learners must understand what is covered in the content in order to successfully answer questions and the use of the necessary skills. Learners will be able to use the knowledge and skills as base for progression to the next week's lesson.
Please like, share, and subscribe to the channel for more future educational videos.
Topic: Structural material. Aims of the lesson. At the end of this lesson you should be able to understand the following concepts: metals, ferrous, mild steel products, description, identification and uses. Metal bars. Metal roofing sheets. Square pipe. Square bar. Round bar. Lip channel. Angle iron. Round tube pipe. Corrosion and prevention. Hardening, softening, tempering, annealing of steel. Introduction. Learning content covered in grade 9 technologies mentioned in the introduction. Today we are going to talk about structures. Name 2 main types of structures. What material would be suitable for the roof of a home, store or store? Concepts and skills. Mild steel. Why do we refer to the term as mild steel? Mild steel has a lower carbon content. It is not as strong as medium and high carbon steel, but is more flexible. It consists mainly of iron. How is iron obtained? Iron is obtained when iron ore is melted together with coke, the fuel, in a blast furnace. Dolomite serves as the flux. Where is mild steel used? Rivets, bolt, nuts, rolled steel sections, steel sheets, wire. Mild steel products. 1. Flat bar, implements, construction. 2. Square tubing, implements, structural bars, tank stands. 3. Square bars, drawbars, implements. 4. Lip channel, roof constructions. 5. Round tubing, water pipes, tank stands. 6. Round bars. Reinforcement rods, bolts, construction, implements. Corrosion/weathering. What is corrosion or rust? Corrosion is the slow process of metal deterioration. This process occurs when pure metals are exposed to oxygen and water, or when other weathering substances such as acids or alkalis combine with it, or when it occurs electrolytically. There are three types of corrosion of ferrous metals: oxidation, rust; electrolysis, weathering by acids, electrolysis. Oxidation occurs when oxygen and water in the air combine with a metal. This process occurs when two different types of metals come together. Acids can also be present in the air, and because they occur in a vapor form, they act on metals, e.g. hydrochloric acid vapor. How can rust be prevented? Oil, grease, varnish or varnish, paint, electroplating. Important when polishing steel: make sure the surface is clean. Heat the metal slightly. Apply a coat of polisher. Let it dry. Rub and polish with a clean cloth. Finishing will take place over time. Polish has a transparent quality. The polisher protects the metal from corrosion. How are enamels and varnishes applied? The surface of the metal must be clean. Determine if the metal is finished. Use a clean cloth or paper to handle the metal. Warm metal slightly so that the varnish will flow well. Use a good clean brush and apply small amounts at a time. Never paint over an area twice. Allow the article to dry in a warm, clean room. If necessary, a second application can be given after the first has dried. Determine the paint base to determine the cleaning method for the brush. Turpentine base: use turpentine to clean the brush. Water base: use water. Hardening and softening of steel. Why is heat treatment applied? Increase the degree of hardness and strength. Increase elasticity/elasticity. Softening metals for subsequent machining processes. Internal voltage caused by switching off the operation. The annealing process has three phases: heating to an acceptable temperature, working through for a sufficient period at a selected annealing temperature, cooling at a controlled temperature. Name the factors that influence the heat treatment of metals. Carbon. Biggest influence. Rate of cooling. Terminology regarding heat treatment. And maximum temperature. Maximum temperature 720 degrees Celsius to where a piece of steel can be heated to achieve efficient hardening upon rapid cooling. And minimum temperature. The lowest temperature 695 degrees Celsius to where a piece of steel can be heated to still be effectively hardened. Temper: the process by which a tool is cooled to obtain a certain hardness. Steel is dampened by heating to an acceptable temperature and then rapidly cooling in oil or water. The temperature to which the steel must be heated is determined by the purpose for which the steel will be used after the time. Matrix: base metal. Critical point: little or no hardening will occur if the metal is not heated to a temperature of between 695 degrees Celsius and 720 degrees Celsius. Malleability: if the ability of the metal to deform without breaking. Slip refers disruption, fragmentation, or matte disruption of the metal to atom when it is reformed by cold. Can only be removed by heat treatment. Surface hardening: the surface of the steel is hardened to a depth of 2 mm by heating the steel in carbon. Cooling. Quick cooling. Carbide was not given the opportunity to separate from the matrix here. In that case, the steel will be rich in carbon and alloying elements. The steel will be very hard. Slow cooling. Carbide will be enabled to separate from the matrix. The end result is that the matrix will be poor in carbon and alloying elements and therefore softer. What does the hot machining process of steel involve? A steel bar has little economic value if it is not converted into a usable form. Hot working is the reforming of a hot steel rod into structural shapes, e.g. rods and plates. A hot steel bar can be hammered, pressed, rolled or forged into other shapes. The reforming of iron is done at a temperature of 450 degrees Celsius. Name the benefits of hot working. Name the disadvantages of hot working. Porosity in the metal has been largely eliminated. Impurities, e.g. carbon, in the form of inclusions have been broken up. Physical characteristics improve. The amount of energy required to bring the steel to its new shape is much less than cold working. Large oxidation takes place on the surface of the metal. No fine tolerance can be obtained due to scaling on the surface. The thickness of the metal increases when heated. Cold working of steel. Metal worked at a temperature lower than the recrystallization temperature. Most metals are cold worked at room temperature. Reform metal by rolling, pulling or pressing it. Name the benefits of cold working. Name the disadvantages of cold working. Finer dimensional tolerance can be maintained. A smooth surface finish can be obtained. Because oxidation does not occur. Increases strength and hardness of the metal. Process is cheap. Larger number of parts can be manufactured faster. A stress that can only be removed by heat treatment develops within the metal. Distortion of the grain develops. Higher pressure and heavier equipment must be used. Overworking has caused the metal to become brittle, and it is necessary to soften it again. Activities/assessment. Teacher must work out activities on the given content and provide them to the learners. During a practical period, learners must be given the opportunity to understand and apply basic concepts of heat treatment. Destructive tests must be done on different samples to explain each of the terminology mentioned above. Learners must design a practical assessment task taking into account the different materials and their properties that are applicable to the task requirements. Consolidation. The lesson covered all the content as prescribed by the CAPS. The learners understand the content, concepts surrounding the materials and the heat treatment process. Values. By studying this lesson, you should be able to know and understand the concept structural material. Learners must understand what is covered in the content in order to successfully answer questions and the use of the necessary skills. Learners will be able to use the knowledge and skills as base for progression to the next week's lesson.
Please like, share, and subscribe to the channel for more future educational videos.
Safety, farm safety. Aims of the lesson. At the end of this lesson you should be able to understand the following concepts. Basic general safety regulations. Safe handling and regulations applicable to all workshop equipment. Farm equipment, as well as skills and construction processes, must be handled by the content, which is covered during the year. Introduction. The purpose of this lesson is to provide content that is associated with the application of safety in and around the work area where the learner will be involved. Concepts and skills. Safety. Occupational Health and Safety Act, OHS Act. Introduction to the OHS Act. Rules applicable to farm safety and the safe handling of machines. General farm safety tips. Do not smoke near fuel tanks, gas cylinders or dusty areas where the cigarette may cause a fire or even an explosion. Do not inhale fumes from the car's exhaust system. It contains carbon dioxide and is extremely toxic. No passengers should be allowed on a tractor's mudguard or any other part of the tractor to drive. Power takeoffs are very dangerous and workers must take care when working with them. Pesticide equipment uses hazardous substances and must be used under extreme care and supervision. If a tractor is operated on a slope, care must be taken that the tractor does not overturn due to a too steep slope. Care must be taken that the tractor does not fall over when pulling heavy objects. Prevent animals and people from coming into contact with mixers, pulleys, tires, blades and chains when using harvesters, hammer mills, cutting machines etc. Avoid working below power lines. Always switch off the machine and wait until it has stopped completely before repair or maintenance performed. Do not wear loose clothing that can get caught in machinery. Similarly, long hair should be tied back or kept under a cap. Use safety equipment. Certain tasks require wearing glasses to protect vision and earplugs to protect hearing. People working near noisy equipment run the risk of developing permanent hearing loss due to exposure to loud noise. Never work under raised mobile equipment, loads or spare parts. Block or support any lift equipment when someone is working on or under it. Get a qualified person who regularly inspects your mobile equipment. If a defect is found, people at risk must be protected and the problem must be repaired before the equipment can be used again. Keep an inspection and maintenance register of services to the equipment. Visually inspect the equipment before switching it on. Check the surrounding area to make sure no one can be injured when the equipment is switched on or off. Activities/assessment. 1. What does OHS means? 2. Name 5 general farm safety tips that have been learned. Consolidation. The lesson covered all the content as prescribed by the CAPS. At the end of the lesson you should be able to understand the content, concepts involving the principles of safety of chemicals. Note, the knowledge and skills you have acquired in these safety sections will help you to better understand the content and serve as an introduction to all the topics covered in agricultural technology.
Please like, share, and subscribe to the channel for more future educational videos.
Topic: Safety, Firefighting. At the end of this lesson you should be able to understand the following concepts: firefighting, fire prevention rules, action when a fire breaks out, emergency evacuation, fire extinguishers, how to use a fire extinguisher, different types of fire extinguishers and information labels. Introduction. The content covered in Grade 8 and 9 Agricultural Studies and previous Grade 10 lessons links in with the content that will now be covered. Grade 8 Safety, Grade 9 Safety, Grade 10 Safety. The purpose of this lesson is to cover content associated with firefighting. Concepts and skills. Fire prevention rules of thumb. Supply, maintain and test fire extinguishers. Make sure all firefighting equipment is accessible and clearly visible. Develop procedures for safe handling and transport of flammable substances. Prohibit use of gasoline for cleaning purposes or lighting fires. Prevent accumulation of explosives, clean the work area if the accumulation exceeds limits. Develop safe working procedures for the installation, use, and maintenance of compressed and liquefied gas systems. The discovery of a fire. If you have a fire detection you should alert immediately by following the instructions at your nearest alarm point. Warn people in the immediate area and evacuate the building. Emergency evacuation. Familiarize yourself with fire escape routes and evacuation procedures in your school and residential accommodation, including the escape routes and the assembly points. Notifications are displayed in all school buildings. Fire drills will be held at least once a year. You should follow the instructions given to you by the teachers, security, or the emergency services. Please be aware of anyone in your area or on your corridor who needs assistance during the evacuation due to limited mobility or special needs. This includes anyone with a long-term disability, individuals who cannot hear an alarm, and, for example, someone with a leg in plaster. Do not use lifts. Do not return to buildings before permission is given by the teachers, emergency services, or security. Fire extinguishers. How to make a to-use fire extinguisher. Instructions for use must be clearly affixed to each fire extinguisher, but in general, remove the safety pin of the handle. Keep the fire extinguisher upright, place it on the ground if it is heavy. Direct the nozzle or nozzle to the base of the fire. Press the handles together. Wipe the radiator over the area of the fire, keep it away from you. Do not get trapped between the fire and the exit, plan your escape route in advance. When to use fire extinguisher. Tackle a fire only after the alarm has been activated and it is safe to do so. Make sure you are accompanied when you go to fight or investigate a fire. Do not do it alone. Tackle a fire only in the very early stage. Make your safety and that of other priority, no heroic deeds. Use only a fire extinguisher if you are sure of how to use it correctly. Do not hold on to the nozzle of a CO2 fire extinguisher, it will get very cold. If the fire is still burning after using up one fire extinguisher, you should not continue to fight the fire but move to the gathering point. If electrical accessories are involved, the power must be turned off before the fire is fought. Do not fight any fire that involve hazardous materials such as oxidizing agents, pesticides, fuel or gas. Containers. Types fire extinguishers. Activities/assessment. Teacher must work out activities on the given content and provide them to the learners. 1. Study the following picture of a fire extinguisher and name the parts. 2. Explain how you will apply the measures to prevent fires in the workshop. You discover a fire in the storage room when working in a workshop. What are the first steps you should take when discovering a fire? The fire department was at your school recently for a fire extinguisher demonstration. They also explained to you the importance of emergency evacuation. Provide the emergency evacuation steps that the fire department has dealt with you. Name the 4 types of fire extinguishers that are used in practice. Also provide the color code of the label on the different fire extinguishers. 3. Look at the fire extinguisher table below and tick the type of fire that each fire extinguisher can extinguish. Consolidation. The lesson covered all the content as prescribed by the CAPS. The learners understand the content, concepts surrounding firefighting. Fire prevention rules. Action when a fire breaks out. Emergency evacuation. Fire extinguishers. How to use a fire extinguisher. Different types of fire extinguishers and information labels. Values. By studying this lesson, you should be able to know and understand the concept safety, firefighting. Learners must understand what is covered in the content in order to successfully answer questions and the use of the necessary skills. Learners will be able to use the knowledge and skills as base for progression to the next week's lesson.
Please like, share, and subscribe to the channel for more future educational videos.
Topic: Safety. Aims of lesson. At the end of this lesson you should be able to understand the following concepts. Electrical safety. General electrical safety rules. Situations that may cause an electric shock. Steps to be taken to secure the person who suffered an electric shock. Safety risks associated with overhead power lines. Dangerous acts and conditions around overhead power lines. Introduction. The content covered in Grade 8 and 9 Agricultural Studies and previous Grade 10 lessons links. With the content that will now be covered. Grade 8 Safety. Grade 9 Safety. Grade 10 Safety. The purpose of this lesson is to cover content associated with electrical safety. Concepts and skills. General safety rules with electricity. Do not play with kites under power lines. Do not climb on overhead power poles or structures. Do not try to loosen a toy that is stuck in the overhead power lines. Do not direct the garden hose in the direction of overhead power lines. Do not touch overhead power lines brought to the ground by storms or fallen trees. Do not climb trees that stand near overhead power lines. Do not throw wire over electrical overhead power wires. Do not replace electric light bulbs, power plugs, lamp fuse holders or anything else without turning off the power supply. Name a few situations that can cause electric shocks to workers. Damaged insulation. Insufficient or faulty earth leakage protection unit. Open electrical wires. Overload of electrical installations. Incorrect connection of electrical wires. A lack of knowledge. Provide in sequence the 7 actions to be taken to secure a person who has suffered an Electric shock. Remove person to a safe place by pulling on his clothes or using an insulating medium, such as rope or gloves, to free him from the point of contact. Loosen the clothes around his neck and make sure he gets enough fresh air. Perform emergency treatment on the person if he/she is unconscious. Use special emergency treatment equipment found in all first aid kits. Bend the head slightly backwards to prevent the person's tongue from blocking the back of the throat. Keep the person warm, calm and comfortable when he/she comes to his/her senses. No liquids should be administered to the person. Call for help. To reduce the risk of electrical injuries with overhead power lines, make sure of the location and height of power lines before starting work near them. Always keep at least 15-meter clearance between any buildings, for example crane silos, and overhead power lines. Cut branches that can touch power lines. Do not allow children to climb a tree near a power line. Make sure the TV and radio antennas on the roofs and elsewhere are at least 3 meters away from all power lines. Do not fly kites and model aircraft near power lines. Never store or handle irrigation pipes or steel reinforcement bars near power lines. Reduce the risk of contact with high voltage power lines. Know safe distances for work near power lines. Know the height of all equipment. Decrease equipment, e.g. mixers, lifts, before being moved for even a short distance. Use someone who knows of minimum distance requirements. Look for power lines when moving equipment. Identify power lines crossing public roads. Plan a safe route for moving large equipment. Never try to lift or move a power line. Activities/assessment. 1. Study the following picture and answer the questions that follow. A and B. 1.1 Explain the general safety rules regarding electricity in picture A. 1.2 Explain some safety measures to ensure that learners do not get an electric shock. 1.3 Name the 7 steps to apply when a person has received an electric shock. 2. Study the following picture about risks around high voltage wires. 2.1 Describe how the people in this picture can reduce injuries around high voltage wires. 2.2 You are an official of the municipality and must warn these persons about the risks of contact with high voltage wires. Provide at least 5 hazards. Consolidation. The lesson covered all the content as prescribed by the CAPS. The learners understand the content and concepts involving electrical safety. General electrical safety rules. Situations that may cause an electric shock. Steps to be taken to secure the person who suffered an electric shock. Safety risks associated with overhead power lines. Dangerous acts and conditions around overhead power lines. Values. By engaging with this lesson, you will be able to appreciate the safety rules regarding safety when working with electricity. Appreciate the importance of safety in a workplace/workshop. Know that safety is important wherever you are working. Value the importance of fire prevention and electrical shock or burn protection. The correct use fire protective equipment. Note, the knowledge and skills that you have acquired in this section will help you to better understand the content and serve as an introduction to the following topic, namely firefighting.
Please like, share, and subscribe to the channel for more future educational videos.
Topic: Safety. At the end of this lesson, you should be able to understand the following concepts. General workshop rules. Safety when working under a vehicle. Injuries in the workshop, cuts, bruises, eye injuries, burns and fractures. Introduction. The content covered in Grade 8 and 9 Agricultural Studies and previous Grade 10 lessons links with the content that will be covered. Grade 8 Safety. Grade 9 Safety. Grade 10 Safety. The purpose of this lesson is to provide content associated with safety. Concepts and skills. General workshop safety rules. Enter and leave the workshop in an orderly manner. Place school bags neatly outside the workshop or at a designated location. Take off your jacket, tuck in your shirt, take off your tie, roll up long sleeves and put on your overalls or overcoat. Wear an apron, gloves, and helmet when doing welding. Take your place at your workstation. Check the tools on the tool rack. Report missing or damaged tools. Each tool must be put back in place at the end of the class. Treat tools as if they were your own. Always keep sharp points of tools in a downward position when carrying them around. Chisel should be away from your body. Use tools for the purpose for which they were made. Wear goggles when using the amaryllis sharpener. Clamp workpiece tightly when drilling with the stent drill. Protect surfaces from stent drilling by drilling on a piece of wood. Use coolant when cutting wire. Do not put screws, nails, and rivets in your mouth while working. Oil moving parts of tools and machinery. Protect tools from corrosion by lubricating them with a thin layer of oil. Report accidents to the teacher immediately. Report broken tools, such as hammer stems, that need to be repaired immediately. Keep the floor clean and dry. Safety when working on or under a motor vehicle in the workshop. Park the vehicle on a level surface. Put the car in gear and pull up the handbrake. Place a stone or block in front of and behind the front wheels when jacking up the rear wheels. The handbrake only works on the rear wheels. Place the jack upright on a hard level surface. Place the top of the jack against a firm place on the chassis of the vehicle so that it does not slip. Use the right size and type of jack. Place box supports under the car when it is jacked up. Do not remove the radiator cap if the engine is still hot. Do not work with an open flame near the petrol tank or carburetor of the car. Injuries in the workshop. Cuts, bruises are injuries. Burns, bone fractures. Treatment of cuts that took place on the farm or in the workshop. Pressure can be applied to pressure points if the bleeding is severe but can only be applied for 15 minutes or until a damper is applied. Pressure can be applied to the bleeding wound itself if the bleeding is not too serious. Make the person comfortable with the injured part higher than the rest of the body. Remove foreign objects protruding from the wound. Clean the wound with running water and clean the surrounding skin with a swab. Use each swab only once. Apply wound cover to the wound, cover it with a small pillow and tie it with a bandage. Make sure that the injured part cannot be moved. Call for medical assistance. Throw all the clothes and bandages used to clean the blood away. Activities/assessment. 1. Name 5 safety measures that this technician must apply to ensure his safety. 2. When you look at the picture below, there are several actions that led to injuries. Give 8 reasons why the person is injured in each picture. 3. Match column A with column B and write the answer under C. Example, 1G. Consolidation. The lesson covered all the content as prescribed by the CAPS. The learners understand the content, concepts around general workshop rules, safety when working under a vehicle and injuries in the workshop, cuts, bruises, eye injuries, burns and bone fractures. Values. Note, the knowledge and skills you have acquired in this section will help you to improve on the content and serve as an introduction of the following topic, namely, electrical safety.
Please like, share, and subscribe to the channel for more future educational videos.
Topic: Safety. Aims of lesson. At the end of this lesson you should be able to understand the following concepts. OHS Law, Introduction to the OHS Act. Introduction. Workshop practices, regulations, rules and procedures. Protective clothing and equipment. Hearing protection. Eye protection. Introduction. The content covered in Grade 8 and 9 Agricultural Studies links with the content that will now be covered. Grade 8 Safety. Grade 9 Safety. The purpose of this lesson is to provide content associated with security. Concepts and skills. Workshop practices, regulations and rules and procedures. Suitable safety goggles, glasses, face shields, welding helmets, shields, hard hats, protective crash helmets, caps, gloves, aprons, jackets, coats, sleeves, leggings, protective shoes, protective overalls, or any similar safety equipment or facilities that will effectively prevent bodily injury. Waterproof clothing, high visibility clothing, chemical resistant clothing, low temperature clothing, chain link clothing. Fire retardant or flame retardant clothing, ice jackets, or any similar safety equipment that will effectively protect the wearer from injury. Belts, harnesses, nets, fall protection, life buoys, safety heels, or any other similar equipment a person effectively will protect against falling. Mats, barriers, exclusion mechanisms, safety signs, or any similar facilities that will effectively prevent slipping, unsafe entry, or unsafe conditions. Protective ointments, earmuffs, earplugs, respirators, masks, trachea, or any similar safety equipment that can effectively protect against injury. Suitable insulation material under the feet where persons walk on a floor made of metal, stone, concrete, or other similar material. In general, such safety equipment or facilities are necessary to keep the persons concerned safe. Protective clothing and equipment. Welding helmet, gloves, apron, respirators, hard hats, protective shoes and protective overalls. Hearing protection. Eye protection. Earmuffs, earplugs and face shield. Appropriate safety goggles, goggles. 1. Study the pictures below and name the safety equipment as well as what its function is. 1, 2, 3, 4. 2. Provide 5 regulations to be applied in a workshop. Consolidation. The lesson covers all the content as prescribed by the CAPS. Understand the content, concepts and concepts surrounding workshop practices, regulations, rules, procedures and protective clothing and equipment. Values. Note, the knowledge and skills you have acquired in this section will help you to better understand the content and serve as an introduction to the following topic, namely, general workshop rules.
Please like, share, and subscribe to the channel for more future educational videos.
Topic: Energy. At the end of the lesson, the learners should understand the following concepts. Electrical energy, 12-volt DC current. Basic principles of electrical energy, current, ampere, resistance and potential difference. Standard symbols and units, volt, ohm and ampere. Basic calculations. Basic components in a car's ignition system. Operation and function. Introduction. Learning content covered in grades 8 and 9 agricultural studies must link in with the current content that will now be covered. Basic 12-volt DC electrical energy. The purpose of this lesson is to expose the learner to the basic concepts of electrical energy and to understand the ignition system of a motor vehicle. Concepts and skills. Electrical energy, 12-volt DC current. Basic principles of electrical energy. Units and symbols. Current, flow of electrons from one point to another. Ampere, symbol I. Resistance, each conductor offers specific resistance to the flow of electrons, ohm. Voltage, the electrical pressure to overcome the resistance of conductor, volt, symbol V. Potential difference, one pole is more positively charged than the other, and since electrons flow from a negative to a positive charge, the charge still exists after the connection is broken. Ohm's law. Current flowing is proportional to supply voltage and inversely proportional to resistance. The magic triangle for calculations. Simple calculations. To determine resistance, voltage and current. Basic components in a car's ignition system. Operation and function. Activity/assessment. Teacher must provide a few examples of basic calculations. Learners use previous papers to complete the part of the work. Consolidation. The lesson covered all the content as required by the CAPS. The learners understand all the concepts and content.
Please like, share, and subscribe to the channel for more future educational videos.